Welcome back to the tutorial course on Android app development. In the previous lecture, we learned how to use Volley for network communication. In this lecture, we will learn how to permanently save the data using the SQLite database. On the next slide, we will learn about the SQLite database. SQLite is an in-process library that implements a self-contained, serverless, zero-configuration, transactional SQL database engine. SQLite is an open-source database. SQLite supports standard relational database features such as SQL syntax, transactions, and prepared statements. On the next slide, we will continue to learn about the advantages of SQLite database. The following are some of the benefits of the SQLite database. SQLite is an embedded SQL database engine. Unlike most other SQL databases, SQLite does not have a separate server process. SQLite reads and writes directly to ordinary disk files. The database file format is cross-platform. We can freely copy a database between 32-bit and 64-bit systems, or between big endian and little endian architectures. SQLite can also be made to run in minimal stack space and very little heap, making SQLite a popular database engine choice on memory-constrained gadgets, such as mobile phones, PDAs, and MP3 players. On the next slide, we will continue to learn about the integration of the SQLite database in Weather app. Open Android Studio. To create and update the SQLite database, Android SDK provides a class called SQLite Open Helper. We will first create a subclass of the same. This will be a skeleton of the subclass we have created. We will name this subclass as Weather app SQLite Open Helper. In the constructor of our subclass, we will call the super method of SQLite Open Helper, specifying the database name and the current database version. In this class, we will need to override the following methods to create and update our database. OnCreate is called by the framework if the database is accessed but not yet created. OnUpgrade is called if the database version is higher than the one in our application code. This method allows us to update an existing database schema or to drop the existing database and recreate it using the onCreate method. We can see an instance of SQLite database is passed on to the preceding two methods. On the next slide, we will continue to learn about the integration of the SQLite database in Weather app. SQLite database is the base class for working with the SQLite database in Android. It provides methods to open, query, update, and close the database. More specifically, the SQLite database provides the insert, update, and delete methods. On the next slide, we will learn to create a locations table in the SQLite database. First, we have to create a table location as shown in the given graphic. We will first create a table called Locations in the database, weather.db, with the columns ID, name, and autolocation. The following code inside the onCreate method creates the table. On the next slide, we will learn to create location model. Now, we will create a model class for locations. Creating a separate model class for each table is recommended for easy access and readability. We can now see that this model resembles the location table that we created considering the variables inside it. We will now create getters and setters for each variable. Now, we have the database and the model. We will now need to create a manager for the same. On the next slide, we will learn to create Location Data Manager. This is a class that acts as a mediator between the database and the UI. It enables us to fetch, insert, update, and delete data from the database. On the next slide, we will learn to implement changes in the UI element. As the last step, we will make changes in the UI element. Here, our UI element is add location fragment. We will now open the UI element. First, we need to change the location list array. Then, we need to read the data from the database. To fetch the data from the database, we will need to create an instance of the location data and use it to fetch the locations as shown in the following code. The getAllLocation method helps to fetch all of the data from the location table. We need to now manually add the location by using the following code. The createLocation method inserts a row into the table with the specified params. AutoLocation is set to 0 when the data is manually added. Similarly, when the location is obtained from the GPS, we will change the location using the following code. We can now see that the parameter AutoLocation is set to 1, denoting that it is a GPS location. We have completed the database integration for the location data. Let's run the app and verify all of the changes are working. This brings us to the end of our discussion on offline data storage using the SQLite database.